Hi and welcome again everyone. In this video I want to go over the transpose of a matrix. And by definition, the transpose of a matrix is formed by writing its columns by rows. That means interchanging column and rows. When you do that, if A is an n by n matrix, then of course the transpose, that's how you write it, is going to be an n by m matrix. A little example here, you have 1, 2, 3, 4, 5, 6, and if you write the transpose, you get 1, 2, 3, 4, 5, 6. This is the first uh, and the third and first entry, which becomes the first and third entry, but the number is the same. So just remember this because we're gonna in the proof we're gonna see that. Now, if you write A is, we can write the compact form. If you write it, A transpose has I, AJ in its Jith entry. So if you change those numbers, you have to, it's the mention that these two are equal. They're the same thing, it just the row and the column changes. You'll see in the first proof. Now the transposes have some properties. Again, the first properties, the properties A transpose, transpose is just A. That's called the transpose of transpose. A plus or minus B transpose is A transpose plus B transpose. And this is the transpose of a sum. CA transpose is the same thing as C times A transpose. That's the scalar multiple. And AB transpose is B transpose times A transpose. Notice B comes first, so it's not A transpose times B transpose, is B transpose times A transpose. This is the transpose of a product. To prove those theorems, again, this works very well. Size analysis and entry analysis, we saw that in the last video. So we're going to do a couple in this video also, so you're going to see. But before getting there, let's just do an example to show how this works. If I have the matrix say 1, 2, 3, 4, 5, 6, then this is got, and B is 3, 0, 1, 2, 4, 7. They are both 2 by 3 matrices. A transpose is 1, 4, 2, 5, 3, 6 is a 3 by 2 matrix. B transpose is 3, 2, 0, 4, 1, 7. Basically, you just interchange the rows and you make them columns. And that's also a 3 by 2 matrix. If we do A plus B, that's what we get, just adding A plus B, the corresponding entries. A plus B transpose is the transpose of that matrix, which I wrote it here. So, and A transpose plus B transpose is just adding that matrix to that matrix. So check the notes, and if you add those, you get this matrix. And we see that they're both are equal to each other. Now, how do you prove this? The general way of proving this. So it says if A is an n by n matrix and B is an n by n matrix, prove that A plus B transpose is A transpose plus B transpose. Size analysis first. A is n by n and B is n by n, so A plus B will be m by n. A plus B transpose is n by m. Therefore, A plus B transpose is an m by n matrix. Now, A transpose and B transpose, they are both n by m and n by m. And if you add them, you do get an n by m matrix. So A transpose plus B transpose is n by m, and A plus B transpose is n by m. So they have the same size. Entry analysis, we can put A in a compact form and B in a compact form. And A transpose, be careful with this notation, and I put the note here. A ij is the same thing as AJI, just the position changes. Aij is the Jith entry of A transpose. So once you put that note, then you're safe. Same as Bij and Bji. So if we use that, it just makes it easier to finish the proof. A plus B is that, we have seen that before. A plus B transpose, I just put that again. Once we have the note, we're safe. And this is an n by m matrix. And A transpose plus B transpose, so it's just adding that. So and we get this in the J-ith position. And as we see, we get the exact same answer. So A plus B transpose has the same entries as A transpose plus B transpose. Now let's go ahead and prove this one also. Given that A is an M by P matrix and B is P by N, these are matrices, and prove that AB transpose is B transpose. Be careful, B transpose comes first times A transpose. Let's follow the same way we prove size analysis. A is M by P and B is P by N. So AB is going to be M by N. We saw matrix multiplication. So AB transpose is going to be N by M. So B transpose is N by P and A transpose is P by N. So B transpose times A transpose is going to give us an N by M matrix. And we see that they have the same size. Entry analysis, please pay attention to this part. Write A and write B in compact form and put the sizes. The ijth entry of A times B, that's from multiplication. If you multiply A times B, you're going to get AIK times BKJ, and the sum of K going from 1 to P, and P is that number. The Jith entry of AB transport is going to have the exact same, this entry. So it's going to be AIK and the AKJ. So these are going to be the same thing, and I call that number 1. Now, if we take the jth column of B, one more time, if you prove, you can just don't write the entire B, it's going to be very long, just write the jth column and say that's B. The jth column of B is B1J, B2J up to BPJ, because this is a P by N matrix. The ith column of matrix A, you can write it like that. Check the last videos again. Don't write the entire matrix, is going to be long. That's good enough. AI1, AI2, AIP, because it's M by P. And I put this is matrix 8. The jth, now if you want to write the jth row of B transpose, the jth row of B transpose is just going to be the jth column of B. So basically it's the same thing, but that becomes the row. So it's right here. The ith column of A transpose, again, is just going to be the transpose of that, but the ith column now. And you can write that like AI1 and then AI2 up to AIP, and that's for A transpose. Now what we want to do is B transpose times A transpose. So if you do B transpose, that means that basically taking this and multiplying it by that. So you can write the summation notation. It's going to be B KJ times AIK. So, but that's the same thing as saying writing that first and then this one second, AIK times BKJ. And I call that number 2. And guess what? If you check number 1, if I go up, number 1, we had that. Number 2, we have the exact same thing. So 1 equals to 2. The Jith entry of AB transpose is the same as the Jith entry of B transpose times A transpose, which is the same thing. So, and this is number 2. So they are equal. So you can finish the proof by saying QED. And I think that's it for this video. Again, watch it 2 3 times and let's see if you can do the other properties and prove it yourself. Thank you and see you in the next video.